Once again, hello everyone, and I welcome you all to my YouTube channel. So today we're going to be doing the remaining topic and the sixth topic of the particular chapter, that is electrophilic ring substitution of phenol and anisole. Okay? 딩의 럽센은 먼저 발전해요. 먼저 럽센은 조 디장해요. 네, 먼저 이 electrophilic ring substitution mechanism TC reaction dinyamdo. What we have done as an output is we have done the chemical properties of phenol. Yes. So the chemical properties of phenol as well. The electrophilic ring substitution also reaction reaction halogenation, sulfonation, nitration, and what do you call it? Fiddle of alkylation and acylation. also 가장 mechanism in case of phenol. Now today we are going to be learning it in case of anisole, or you can say any type of what do you call that? Any type of compound like this benzene ring, you can O group, ethyl group and then R group the mechanism do now for simplicity also validation anisole, okay? 직관직견에 가상 장소에서 OH라는 장소에 상호 autoparadigmatic activating group 돼. 직관직견 OCH3 역할의 activating group 돼. 가상 어디 거의 자기 직관직견 시대. 혹시 auto는 내에서 negative charge be어지는 positive charge 부분에 that 거의 노래스나 가상 어디 they have not drawn the double bond in the previous video. So double bond second, third, fourth the double bonds and fifth the slow one has again lesson. Okay. Now there are and then parallel the parallel the double bond and the double bond and there are also the so the same mechanism is followed. And it's all that are did no benzene ring with OCH3, that is C6H5 OCH3 is your anisole. Which is what this is your anisole. Then 먼저 가지 않네 halogenation. Okay, halogenation reaction 하고니 phenol and anisole 이거 알죠? Ether the phenol the halogenation when we react phenol with Br2 so parallel forms Br. Okay, this is your what do you call that? Every Br3 is your catalyst reagent. Now Br parallel is your major product. Okay, parallel is major there. Now ortho product that is orthobromophenols. Parabromophenols is major, where orthobromophenols is minor. Okay, so less amount of deformed check, more amount of deformed check. When we do the reaction with anisole, the same reaction takes place. Instead of OCH3 gasha, Br gadani, now there is an exception which is quite important. Okay, the exception is quite important, and that's why I have written that here. This is the exception. Okay, okay, so this is the exception, the pink one purple color. When you react phenol with Br2 excess Br2, yamina aqueous bromine, that is your bromine water. Is it here the bromine water in reaction? Bromine water, aqueous bromine is called bromine water. Bromine water now Br2 excess in the reaction. And if you do the reaction in such a way, then you will get a different product instead of ortho para product. Okay, here I do it. What's the ortho position parallel try product which is a white PBT. Distinction test now the but actually it's a type of electrophilic ring substitution chemical test. This is a white PBT. Okay, because this is a white PBT. White PBT what is because the wala settle down in the form of solution. Okay, plus try product HBr. Okay, HBr. Tata 1, 2, 3, 4, 5, 6, 2, 3, 4. The name is 2, 3, 4, 2, 2, 4, 6, 2, 4, 6, 2, 4, 6. tribromophenol. The 2,4,6 tribromophenol. The next one is sulfonation. Exception 지나죠. 너什么 orthopelarona 찍과 찍기하네. Okay. Now sulfonation. Sulfonation 나 같이 이거데 sulfonic group SO3H 이 걸고데. Now when you react phenol with sulfuric acid only, then what happens? Sulfonation takes place. Sulfonation channel 같이 phenol beta position na SO3H plus OH group beta position na SO3H plus. Okay, so naming is quite easy. The minor, the major, the minor. The naming is 4-hydroxybenzene sulfonic acid. Okay, sulfonic group is major. This is what is the main the gelatin. 4-hydroxy, 1, 2, 3, 4. 4-hydroxybenzene sulfonic acid. 2-hydroxybenzene sulfonic acid. Now next one is when you react any stool with sulfuric acid, same thing. Check by check here. Benzene ring mana OCH 찍고 가야 돼. 와라 sulfonic group 당기로 찍고 SO3H plus benzene ring OCH3 SO3H plus. Now when you do that, naming is like this. The major, the minor. Now the naming is okay. The naming is 1, 2, 3, 4. The fourth position, let's say, what is this? This is methoxy. So 4-methoxybenzene sulfonic acid. 4-methoxy because ether 4-methoxybenzene sulfonic acid, or this is your 2-methoxybenzene sulfonic acid. Yamana para-methoxybenzene sulfonic acid, ortho-methoxybenzene sulfonic acid. The next one is nitration. Now nitration, the sulfonation is capable. You just need to know the difference between sulfonation and nitration because they are quite confusing. Now when you do the reaction of phenol or with anisole with nitric acid along with sulfuric acid, what happens is sulfuric acid acts as a catalyst and does not get involved in the reaction. Reaction that involves chagi mane. So the one that is involving is your nitrosonium ion, or you can say your NO2 group. Okay. So NO2 group what you will get here is benzene ring. Benzene ring kana phenol OH yore. And this side is NO2. Then benzene ring OH group. And then NO2 group. Okay. So this is how it is done. Oh, good. You will get the same product in the second reaction as well. Now the fourth one is your Phenols alkylation. Now Phenols alkylation we have to react phenol or whatever you are taking, the main reactant, with a haloalkene. Haloalkene will react in the presence of anhydrous AlCl3, which is your catalyst. Then product OCH 라서 orthopada directly para is your major product. Now para CH because this is alkylation, right? Alkylation means alkyl with H. So the group you got the para ortho H, okay, in the fixed ratio, and HCl will be your side product. That's how. Orthola plus HCl is the side product. This is major, this is minor. That means 4-methyl anisole, 2-methyl anisole. Yamena means okay, you can call it 4-methyl anisole or you can call it 4-methoxytoluene as well. Now when you react phenol with this one, okay, this one another CH2 Cl delagation. Okay, we have CH3, CH2, CH2, Cl. कुछ जो any doubt in add here क्या कहीं का बोले stability maintain चुनती कुछ वाचा. So देला क्या कहीं phenol जो OCH3 शायद degree sama reaction जी पर है now phenol नम reaction ना पैरा division पैरा नहीं draw चुना क्या ना product कहीं लगे इसमें. There are bond CH2, CH2, CH3 gado hole, but that is not correct. Okay, CH2, 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 CH3 gana, the answer will be wrong. Why? Because stability should be maintained. Okay, the mechanism na tha wo chlorine माध्य the carbocation chadu bole. Now carbocation which is more stable? Carbocation tertiary is more stable, but there are tertiary very chance but it can form a secondary form, secondary carbocation which is more stable than primary. कुछ उसमें तो कैसे क्या ये CH2 CH2 CH3 then they go in a positive charge neutral. This is your primary carbocation, okay, which is less stable as compared to this one. The more stable the less stable Stability this is more stable because secondary this is less stable because this is primary. Also so then CH3 CH3 any what is that bond CH3 CH3 because we get को secondary carbocation form चाहिए कुछ इस बार जब पैरा in case of middle half alkylation where stability of carbocation is an important factor. Fifth one, middle half acylation. The acylation के लिए होने खाने को है ना वो दाम नहीं गया कुछ तो ये negative है ना वो दाम नहीं खाने पैरा था और थोड़ा गया जला complexity खाने होने लो इस क्या है इस बार ऐसा आंसर OCH3 COR Gasha plus the main minor product will be OCH3 COR which is what minor product. Phenol naming naming is important, but we should know it from class 11 the chance of now phenol COCH3 plus phenol OH COCH3. Okay, the product has the last one. Okay, phenol. Okay, so OCH3 COC6H5 plus OCH3 COC6H5. So this is how the graph acylation is all about. And the reactant, the NSO key also parallel donate. This is how the mechanism is working in case of orthoparallel reacting group like these four. The strand sequence did so if you have not written these notes, just write it. I'll give you 1 second. Okay, pause the video and do it. Okay, so now we will do the 7th topic of this chapter. Okay, that is the second last one. Okay, the second last one, Nanda. What we're going to do is we are going to do this topic, that is preparation of ether. The alcohol, the phenol zone, preparation of ethers. Even though ether is an important topic, there is not much to learn in our syllabus. Ether first one is preparation of ethers through Williamson synthesis reaction. Williamson synthesis. Williamson synthesis reaction. I think we have done it in the first chapter, okay, but we'll do it again because we have to do it in this topic. Now, Williamson synthesis reaction. Now, Williamson synthesis reaction means what? We are synthesizing ether from alkyl halide CH3, CH2, Cl dose. यामध्ये क्या है CH3, CH2, Br okay, you have to take alkyl halide, react it with CH3. Okay, now react it with CH3ONA. Okay, plus CH3ONA. Which is what? Now in this reaction, what you need? So have CH3ONA. Okay, you need the CH3ONA go but RONA group go. Okay, sodium alkoxide go. Here, what you need is sodium alkoxide. Sodium alkoxide. Sodium alkoxide go RONA. So R can be anything. CH3 gonna degrade, CH3 gonna degrade. For simplicity in CH3 gushing. Okay. Okay. So this is your primary and this is your secondary. Sorry. They are primary. These are primary alkyl. Now the reaction can occur. The group CH3O group. The group will be joined to CH3CH2 and Na goes with Cl. So what we get is CH3, CH2, OCH3. Okay, plus NaCl. CH3, CH2, OCH3 plus NaBr. Okay, so it's a type of nucleophilic substitution. But there's a condition, you cannot take secondary or tertiary alcohol in this reaction. Okay, we can't take secondary and tertiary alkyl halide or alkyl halide in this reaction. Why? CH3, CH, Cl. This is your secondary haloalkane. Secondary haloalkane is CH3ONA. What happens is elimination takes place. Okay, this is substitution reaction. Substitution interchangeable. But here what happens? Elimination takes place. Elimination now elimination what you will get is CH3 CH double bond CH2. This will be your main product. Alkene okay. Deni HCl matosha. Deni HCl matona CH3 OH plus NaCl will be your product. Tata. Elimination chana what happens is this side the hydrogen so the hydrogen the CH3O numero the chlorine the Na numero. Okay, and this is the main product that we get, which is an alkene. Okay, so this is the condition of Williamson synthesis reaction. Okay, you cannot take secondary and tertiary, intermediate, primary, alkyl halide ground liquid. Now for second, this is important. Now the second preparation is from alcohol. Okay, preparation from alcohol. Alcohol is also preparation. What you have to do is you have to take an alcohol, CH3, CH2OH ratio, that is your ethanol. Okay, now you have to heat ethanol at 413 Kelvin of temperature, not more than that, okay, or not less than that as well. Heat, what you will get is CH3, CH2O, CH2, CH3. You will get a double number of carbon. You will get an ether having double number of carbon of that of reactant. So there are two Gersha. 2 CH3, CH2OH, 2 Gersha plus water. So you will get a product like this. Okay. But exception check. Okay, exception check did you show? Exception but when you heat alcohol CH3CH2OH at 443 Kelvin, that is 30 Kelvin more than the previous one, heat march. What you will get is you will get an alkene. CH2 double bond CH2. Okay, plus water. So this is an exception. And what the chemical properties of alcohol. Okay, so now we are done with the preparation of ether. Temperature is okay. Okay, so now the next topic, that is 8.1, is your chemical property. Chemical properties of ether. Okay, ether property, but the one that is often asked in your exam is the substitution mechanism. Okay, as we don't have much time, so they do the chemical properties substitution. Okay, substitution with HX number. That is your okay. So this is your acid. HX and acid drop. Now substitution with HX reaction example first example number 8. Suppose you take an ether, that is CH3O CH3. Okay, this is your ether, that is your methoxymethane. Methoxymethane. Okay, this is your methoxymethane. Now, when you take methoxymethane, you have to react methoxymethane with HX. HX can X can be either chlorine, bromine, iodine, or fluorine. So you have question the criteria iodine. Okay, so let us write HI, because HI reaction the most sufficient, because HI the bond length hydrogen X HX की case HX I की case okay, X की case I bond length पे that's why the reaction can take place quickly. Then I can react to it. Now what happens is iodine HD O number 2 IDC. What you get is you will get CH3 OH plus CH3 I. So you will get an haloalkane. with with an alcohol. Last one. The yellow because both the sides consist of same number of carbon, right? The Kc and eno. The Kc and eno CH3, CH2, O, CH3, and eno. Okay, plus HI. Kc and eno. Any question? If the case is like this, what happens is when balance is maintained. Balance maintained. CH3 CH2 is more bulky. CH3 CH2 is more bulky mass share. So what happens is H na I ni switch on H2 on. So H the bulky to negotiate. I the 2 on negotiate. So balance is maintained. So question is 2 on negotiate. Which share is 2 on. So CH3, CH2, OH are okay, you get ethanol with iodomethane, or you can say methyl iodide. Which is what? Same case because the dinam with anisole. Anisole which you are using. Dinam. If you react anisole with HI, so this reaction takes place at 373 Kelvin. 373 Kelvin. But you just have to know that 373 Kelvin. 373 Kelvin is 100 degree Celsius. The reaction takes place. Now, anisole in the reaction now, CH3 is less bulky. So iodide give hydrogen D O because ring the more bulky. So what happens is you will get phenol as a product. Phenol with methyl iodide. यहाँ देखना exception चाहिए होता है यार, which is very important. Okay, exception चाहिए होता है. The exception लिखा है because we have to consider secondary and tertiary as less bulky. Okay, secondary tertiary जो primary ले less bulky होते हैं. कहना ये होता है carbocation और carbon part भी. Okay. खासी जो है surface area degrees है वो है. जैसे कि यहाँ question लिखते हैं ना, right यहाँ CH3 लिखते हैं ना. Okay, CH3 लिखते होते हैं. ये यहाँ ना कहते होते हैं CH3 CH3. So if I ask you a question, which is more bulky, क्या लिखा ना तो वो the bulky दे रहा है. इन्हें the मारे CH3 is more bulky. Why? Because CH3 the primary. Okay, CH3 the primary दे दो. Okay, CH2 है ना primary दे. Okay, primary दे दो, दिखा दे दो. Secondary दे दो. So even though carbon माँ है ना यार, we have to consider it as more bulky and the other one as less bulky. कुछ उसवा. So every है ना, क्या ये भी चुनते हैं CH3 CH CH3 O CH3. Okay, see any dose example tena in which you have a secondary carbon part as well as a primary carbon part. नहीं हुआ primary carbon की part check to secondary carbon की part check to. So what happens at 373 Kelvin? So the question is this is less bulky. Okay, when you react it with HI in the reaction ना क्या ना CH3 CH3 drop बिनियम drop iodine dosage भी गोल सुबह experimental data ले plus यहाँ ना CH3 OH दे कुछ उसमें example last दिखते हो tertiary example दिखते हो CH3 CH3 O CH3 कैसे ये dose है ना that is your tertiary carbon ले this side is primary ले कुछ उसमें the HI reaction ना HI reaction ना this side is less bulky. Okay, so iodine with this side hydrogen and hydrogen the carbon hydrogen. कुछ उसमें so क्या लिखा है दूसरे CH3 क्या लिखा है दूसरे CH3 branch CH3 with iodine hydrogen कुछ उसमें plus क्या ना methanol कुछ उसमें. So this is how substitution takes place in case of ether along with H6. Which is what. Now with that, I just want to say that the chapter is almost complete. Okay, all the important topics from board point of view is complete. Now the one small topic that is not complete is the mechanism of dehydration and hydration. Dehydration of alcohol and hydration of ethane. So what I will do in the next video, I'll be covering dehydration of ethanol, that is your alcohol and hydration because both of them are quite simpler. The first step, you have three steps. First one is your protonation, second one is your carbocation formation, and the third one is your deprotonation, removal of proton. So what I will do is I will do dehydration in the next video along with the important MCQs and questions, that is previous year questions of this chapter. Okay, till then study hard. Don't forget to like, share and subscribe my channel, and keep studying hard and have a good day.